On this 2015 to 2025 Ford F150 with the 2.7L EcoBoost, 238 kilowatts, 324 PS. P0306 means the PCM has detected a misfire on cylinder 6. In plain terms, that cylinder is not contributing the way it should. The truck may idle rough, stumble under load, feel down on power, or set a flashing MIL if the misfire is severe enough to risk catalyst damage. The fault area may be ignition, fuel delivery, base engine condition, vacuum or EVAP leakage, EGR behavior, sensor input, or an intermittent crank signal issue. If the MIL is blinking once per second, treat it as a catalyst risk misfire. Also remember that startup misfire information may involve the first 1,000 revolution test interval following engine start, so captured conditions matter. Before clearing codes, record the freeze frame information, because clearing PCM DTCs erases that captured data. Start with the basic system checks and look at the full code picture. If another code points you toward a cam or crank synchronization issue, handle that branch before treating this like a simple cylinder misfire. If P0306 is the active misfire path, pull the PCM misfire freeze frame data, record the available PID values, and compare them to the normal reference values. If something in that captured data is out of range, move into the proper follow-up testing for that area instead of guessing. Next, run the relative compression test. If all cylinders pass, continue. If a suspected cylinder does not pass, use cylinder leakage testing, and if leakage passes, use a compression test on that suspected cylinder. After that, check for other non-misfire continuous memory codes, then KOEO codes, then KOER codes. If any of those are present, set P0306 aside temporarily and diagnose the next code first. Now run a power balance test. If every cylinder is contributing correctly, move on to injector flow testing. If cylinder 6 is not contributing correctly, go into the ignition branch for the suspect cylinder. In that ignition branch, confirm the code picture again with the key on. If a transport mode code is present, deactivate transport mode, clear the PCM DTCs, and repeat the self-test. Otherwise, if the cylinder misfire path is still present, run the ignition side power balance check. If all cylinders contribute there, do a visual ignition inspection. Make sure the coils are fully connected, check the harnesses and connectors for damage, heat, looseness, or broken conditions. Make sure the battery is in good condition, and keep accessories off. If the power balance still shows a problem, go straight to suspect coil power testing. Keep in mind that some scan tool tests may not be available on every vehicle. When that happens, follow the pass branch for that test. Also, do not disconnect any COP while the engine is running, because that can damage the COP or the PCM. If the ignition system has been damaged, take a look around the catalyst and muffler area for heat damage. At the suspect coil, key off, disconnect the coil connector, then key on and check VPWR at pin 3 for the suspect coil connector. On this 2.7L EcoBoost path, voltage must be greater than 10.5 volts. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. If VPWR is good and P0306 is still the cylinder-specific misfire path, continue toward the cylinder spark test. The bank check matters here. On 6-cylinder engines, cylinder 6 is on bank 2. The cross-bank component swap step is used when the routine is comparing a bank 1 cylinder against the opposite bank. For this cylinder 6 path, the bank decision sends you on to spark testing. Disable the fuel pump by removing the fuel pump fuse, disconnect the ignition coil from the spark plug, and connect adjustable ignition spark tester, THX458, or equivalent to the coil boot. Set the tester to 40 kV and crank the engine 3 times. Then set it to 25 to 28 kV and crank while watching the tester. A correctly operating ignition system only needs to show spark in the 25 to 28 kV range. If spark is not present there, install a new coil or COP, clear the PCM DTCs, and repeat the self-test. If the ignition path is not narrowed to one cylinder, use the same spark test setup across all cylinders. There is also a component inspection variant for a different engine family, but on this 2.7L path, once spark is present, continue with the spark plug checks. Remove and inspect the spark plug for damage, wear, carbon tracking, deposits, and correct gap. Then, Measure spark plug resistance from the center wire to the terminal. At 25 degrees Celsius, it should be between 2,000 ohms and 12,000 ohms. If it is outside that range, install a new spark plug, clear the PCM DTCs, and repeat the self-test. Once coil and plug checks pass, decide how you got into this branch. If you came from the earlier cylinder misfire routine, return to injector flow testing. If you got here from a symptom-only path, continue with that symptom-based path. If neither path is clear and the concern is acting intermittent, pause, recheck the earlier diagnostic path. If the ignition branch does not find the cause, continue in order with the relative injector flow test. If all injectors are flowing correctly, keep going. If one is not, check for a loose connection and damaged or corroded pins. Repair as needed, and continue to the fuel system checks. Next, follow the fuel system diagnostic path. If a fuel concern is found, repair it. Clear the PCM DTCs and repeat the self-test. If no fuel concern is found, inspect the vacuum hoses for damage, deterioration, or restriction. Some vacuum leaks can be heard. Also inspect the EVAP lines and hoses for wrong connections or damage. After that, bring the engine to normal operating temperature and monitor the EGR VPDES percentage PID. Record it at idle, then record at key on with the engine off, and compare both readings to the normal reference values. If the EGR values are out of range, diagnose the EGR system. If they are in range, shut the key off, disconnect the EGR assembly connector, and try to recreate the misfire using the captured conditions and customer information. EGR-related codes may set during this disabled EGR check, and the vehicle may need to be driven to recreate the original complaint. If the symptom cannot be recreated, remove and inspect the EGR for contamination, unusual wear, carbon deposits, binding, or other damage. Then repair as needed, clear the PCM DTCs, and repeat the self-test. If the misfire can still be recreated with the EGR disabled, move into base engine checks. Look for things that can disturb cylinder acceleration or engine integrity. Accessory drive drag, a mechanically driven cooling fan where equipped, compression and leakage problems, valve train issues, PCV leaks, other base engine component concerns, and IMRC linkage problems where equipped. Engine temperature may affect these results, so keep that in mind while testing. If a base engine concern is found, repair it, clear the PCM DTCs, and repeat the self-test. If no base engine concern is found for P0306, start the engine and command the suspect injector off with the injector disable PID. If engine RPM changes, continue to the later checks. If RPM does not change, inspect the suspect fuel injector connector and pins for damage, corrosion, or incorrect connection. If those checks show no concern, install a new fuel injector, clear the PCM DTCs, and repeat the self-test. If the vehicle does not provide injector disable PIDs, follow the pass branch for that step. After the fuel injector decision point, check for electrical and rotational inputs that can make the PCM see a false or intermittent misfire. If the earlier code check sent you into the cam sensor branch, monitor the SYNC PID and verify CMP sensor installation before continuing. Then check the generator for excessive electrical noise. Listen with the engine running, shut the key off, disconnect the generator regulator B+ connector, restart the engine, and decide whether the noise remains constant. If the noise drops when the B+ connector is disconnected, diagnose the noisy generator condition. Next, inspect the CKP harness for damaged wires or other physical damage, because that can create an intermittent short in the CKP circuit. Then inspect the crankshaft pulse wheel for damaged teeth, wobble, looseness, crank pulley wobble, and CKP sensor damage. If that area is not okay, repair is needed, verify correct CKP sensor installation, reset cam, and carry out the misfire monitor neutral profile correction with the scan tool. After that, check for biased oxygen sensor data by monitoring EQ-RAT11, EQ-RAT21, long FT1 percentages, long FT2 percentages, and short FT2 percentages, and comparing anything suspicious to the normal reference values. If the data points to a biased HO2S, inspect the HO2S exhaust system and HO2S mounting flanges for leaks or damage. Repair as needed, clear the PCM DTCs, and repeat the self-test. Finally, check whether recent repairs involved rotational components such as the crankshaft, crank pulley, camshaft, flex plate, flywheel, pistons, connecting rods, or front accessory drive components. Misfire profiles may need to be relearned after major engine work. If that repair history is present, perform the misfire monitor neutral profile correction, recreate the original conditions, monitor cylinder misfire data in mode 6, and verify the misfire count is below 10. If the path ends in follow-up testing that is not available in front of you, pause, recheck the earlier diagnostic path, and avoid guessing. Keep verification separate from the testing. Anytime a repair is made, clear the PCM DTCs, repeat the self-test, and recreate the captured or customer-described conditions to confirm P0306 stays gone. The takeaway is simple. Do not jump straight to a coil or plug just because the code names cylinder 6. Prove compression, code priority, power balance, ignition output, injector behavior, air leaks, EGR influence, base engine condition, crank signal integrity, and misfire profile in order. For more diagnostic training, visit stepdiagnostics.com.